Welcome to part 3 of the CipherVibe Cloud Security Capabilities series. This episode explains cloud security posture, why it matters, how the capability works, which mistakes weaken it, and how to build it in a measurable way. Cloud Security Posture Management discovers cloud resources and evaluates whether their configurations create preventable exposure or violate policy. Effective posture work connects configuration evidence with identity, network reachability, data sensitivity, and business ownership. The key idea is that a security capability is more than a product feature or a collection of alerts. It combines people, process, technology, decision rights, evidence, and continuous improvement. We will examine its architecture, operating workflow, failure modes, defensive controls, implementation roadmap, and useful metrics. Coverage is not the same as effectiveness. A dashboard can show thousands of checks while the capability still fails because evidence is stale, ownership is missing, or remediation is never verified. The business outcome should be explicit. Teams need to know which loss scenarios the capability reduces, which systems are in scope, and which remaining risks require a conscious decision. To understand cloud security posture, start with its architecture and vocabulary. The capability should create a traceable chain from source evidence to a security decision and then to an accountable action. First, cloud inventory spans organizations, subscriptions, projects, regions, services, tags, relationships, and resources created by automation. Second, posture rules translate provider guidance, regulatory obligations, and organizational standards into testable evidence. Third, contextual prioritization distinguishes an isolated development resource from an internet-exposed production asset holding sensitive data. Fourth, governance includes preventive templates, detective monitoring, documented exceptions, remediation ownership, and verification. These concepts need shared identity, timestamps, provenance, ownership, and access control. Every summarized risk should link back to its source evidence and disclose missing information. A sound architecture separates collection, normalization, analysis, policy, workflow, and presentation. Teams can then test freshness, identity resolution, policy results, owner routing, and closure independently. Design for degraded conditions. Providers impose rate limits, schemas change, credentials expire, and events arrive late. A professional capability reports uncertainty and health instead of presenting incomplete information as fact. Trust boundaries deserve equal attention. Identify where data crosses accounts, tenants, regions, vendors, privilege levels, and administrative domains, then apply authentication, authorization, validation, encryption, and audit controls at those boundaries. A useful operating model for cloud security posture follows a repeatable evidence lifecycle. First, onboard cloud organizations using read-only roles and confirm complete account, project, region, and service coverage. Second, establish a baseline, suppress duplicates, map resources to owners, and identify missing business metadata. Third, prioritize findings using exposure, privilege, data, exploitability, lateral movement, and operational importance. Fourth, route changes through infrastructure as code when possible and use direct remediation only with explicit safeguards. Fifth, reevaluate the resource after change and watch for configuration drift or recreation by an unchanged template. The workflow does not end when a ticket closes or an API returns success. Security closure requires fresh evidence showing that the risky condition is gone and does not immediately recur. Ownership should be established before urgent findings arrive using service catalogs, business applications, on-call schedules, and escalation paths. Prioritization should explain the influence of exploitation, reachability, privilege, data, business criticality, compensating controls, and confidence. Repeated findings should drive changes to secure templates, defaults, libraries, identity patterns, and architecture standards. Define escalation points for missing owners, disputed priority, failed changes, and evidence that suggests active compromise. Those conditions should move into incident or risk governance rather than remaining indefinitely in a routine queue. The fastest way to evaluate cloud security posture is to study how the capability can fail. First, benchmark compliance can look healthy while a small number of reachable attack paths remain severe. Second, read-only connectors may miss newly introduced services or regions if their permissions are not maintained. Third, automatic fixes can interrupt production when dependencies and ownership are unknown. Fourth, console changes reappear when the underlying template or pipeline remains insecure. Fifth, exception lists become permanent blind spots when owners, reasons, and expiry dates are missing. These failures share a pattern. A local measure looks successful while the full outcome is weak. A connector, scanner, or repair can report success while coverage, exploitability, or recurrence remains unresolved. Measure whether the program improves important coverage, shortens exposure time, removes attack paths, and prevents recurrence, not how many alerts it produces. Exceptions need a reason, owner, compensating controls, approval, and expiry. Automation should reflect confidence, reversibility, blast radius, and business impact. Test both through controlled failure exercises. Correlate weaknesses instead of reviewing them separately. A moderate configuration issue, broad identity grant, exposed service, and sensitive data store may combine into a severe path even when no individual alert looks critical. A dependable cloud security posture program uses defense in depth. No single scanner, policy, gateway, or agent should be expected to carry the entire outcome. First, use organization-level discovery, coverage monitoring, and alerts for unmanaged accounts or disabled audit services. Second, combine standards with custom policies reflecting approved architectures and data handling requirements. Third, enrich posture findings with identity, network, vulnerability, runtime, and data context. Fourth, prefer pull request remediation with tests, approvals, rollback plans, and evidence-based closure. Fifth, govern exceptions as time-bound risk decisions with accountable owners and compensating controls. Control design should include preventive, detective, responsive, and recovery layers. Together, they establish safe defaults, identify drift, govern containment, and restore service. Least privilege applies to connectors, agents, orchestration identities, data stores, and administrators. Scope, separate, monitor, rotate, and test their access. Every control needs an owner and test strategy. Validate it with representative assets, negative cases, simulated attacks, provider failures, and rollback exercises. Integrate controls with engineering through clear pull requests, owner routing, reusable fixes, documented standards, and fast feedback. Preserve an evidence trail from detection through decision, approval, change, and verification. That lineage supports investigations, audits, lessons learned, and fair performance measurement without forcing teams to reconstruct history from separate systems. A practical implementation roadmap for cloud security posture should build trust before scale. First, begin with complete inventory and a focused baseline for logging, public exposure, encryption, and privileged access. Second, assign ownership and business criticality before expanding role volume. Third, add infrastructure as code checks and remediation workflows for recurring issues. Fourth, build attack path correlation and preventive controls around the most consequential architectures. Fifth, review metrics by business unit and root cause, not only by cloud provider or role count. The roadmap is incremental because a focused production scope lets teams validate evidence, ownership, workflow, and control safety before scaling. Useful measures include cloud account coverage, public exposure age, critical posture fix time, exception expiry compliance, and recurrence after remediation. Give every metric a precise definition, data source, owner, and known limitation. Pair lagging indicators such as exposure age with leading indicators such as coverage, control health, exception expiry, and secure template adoption. Maturity means the organization can discover important risk, explain it, assign it, act safely, Verify the result and learn from recurrence. Review the roadmap quarterly. Changes in architecture, threat activity, regulation, business strategy, and provider services can alter both priorities and assumptions. Retire metrics and controls that no longer guide useful decisions. For more cybersecurity market intelligence, research, and educational briefings, visit CipherVibe.com. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access or test systems without explicit written authorization.